As you see, the topics of our course, it's the process dynamic and control. Process dynamic and control. References we are going to use. The first one, it is available as a textbook at the university. Superb. The title of the textbook, Process Dynamic and Control. There is even a new edition in 2000, but the available at the bookstore, it's this edition, the first edition. Other topics, it is there, one by Stephanopoulos, the other one by Leubel, Process Modeling, Simulation and Control for Chemical Engineers. And there are others around additional 5 topics in relating to the process dynamic and control. They are different title, but all of them related to the process dynamics and control. We are studying, I will come to that shortly, inshallah, to the dynamics of the control process and then the control. There are other disciplines in the engineering, like electrical engineering, electronic, computer engineering, mechanical engineering. Those disciplines, they do study control, but their process is different than our process. So sometimes we can go for process books and control books. That's another option. What's the major difference between our equipment and their equipment? Their equipment very fast. Like they would like to control the pump speed, motors, or switch. For example, even the signal in the mobiles, it is very fast. Nobody like the signal to be slow. So their process have what we call a time constant or residence time, very short, in microseconds. But our process, it is a big tank. When the process feed comes and out, it takes sometimes hours to see the behavior of the process. That's why we need to study the dynamic in details. Compare in their discipline, they concern about the control more than the dynamics of the process. This is from the beginning. So this is the references. So our topics, process dynamics and control, it has 2 titles. One, as I said at the beginning, process dynamics. Process dynamics. This is, we name it time varying behavior. Time varying behavior of process variable. What it means, dynamics? It means change with time. Change with time. So the variable change, let me put it in here, of variables with time. تغير مع الزمن. Because if everything fixed, there is no need for control. When we say dynamics, it means changing. For give you example, this is a reactor. We control the temperature of the reactor. This is the temperature. With the time, what is the behavior of the temperature with the time if there is a change? Simply, as you understand, when we do have a heat exchanger, for example, and there is a cooling media in the plant operates 24 hours. At night, the cooling water, if it comes from the sea, it is a little bit cold. But during the day, the temperature will rise up. So the feed of the temperature will rise up of the cooling media. So that will affect the output temperature. So that changes during the day. How will affect that temperature? How? And how long if the control system will come back? And what is the size of the change? Sometimes the temperature just rises like that, sometimes it goes higher. So what we need to study the dynamic of the process, not just the temperature, maybe the pressure, maybe the flow, maybe the level, maybe the concentration or pH. These are the variables we have to study the dynamics. If we understand the process, then we will understand how to build a control system for that particular process. I give you a simple example in your life. When you are driving a car, and some of you have a car, before you accelerate, what you do? You look to the street, you look to the road, to the traffic. If the road empty, so your eyes is sensing part. What it does, it sends a signal to your mind, it said the road is empty. And your mind will send a signal to your leg to press the petrol, to speed up. So what you did, you study the environment of the road. You study the traffic. So that's what we said. First, we have to know the dynamic of our process, and then to put a control. The dynamic, this is change with time. It means solving the differential equation. Solving differential equation. So differential equation is the process model. That's the basic things. So we'll come first to study the model of the process, and then we'll go after that to continue our subject. That's first part, the process dynamic. That's first part we are going to study for, let me say, around 6 weeks, and then we go 6 to 8 weeks, and then we go to the other part. Second part is the process control. Process control. Process control, actually, it deals with the quality of our product. You see, the feed to distillation column should be at constant temperature and the flow rate. You remember in the design of distillation column, the feed temperature, it is very important because it specifies the feed where it's about. Changing the feed temperature, changing the Q line, it means changing the slope of the top and bottom operating line. It means changing the number of trays. You see, so you have to control when you design distillation column based on feed temperature. It means you are going to fix that temperature. So you have to do your best how to control that temperature, as well as to control the level in the drum. Control the level in the drum, it means controlling the reflex ratio to control whatever inside the distillation column. Similarly, to control the bottom temperature by using the steam. So you see, for that particular part, you need an output from the distillation column. This is what it deals with, the quality to produce a uniform product, quality, and meet customer specification by controlling one process output and by manipulating one of the process input. So what it means, you choose what you would like to control, what variable, temperature, concentration, levels, or all of them. But each particular variable must be manipulated by another process input. So what's the input to the process? You choose one of the input, so you measure the output variable and manipulate. تتحكم بأحد الدواخل لهذا البروسيس، أحد الفيد. Regarding customer specification, many plants, they do produce a paint, أصباغ. So we expect, we are, sometime you or myself or other people as a customers, when they go to the shop and buy particular color, a can of paint, and use it. So if you buy multiple paints, can of paints, you should have the same color, same specification regarding viscosity, density, and so on. If the product differ, nobody going to trust that particular product. إذن المنتج لابد وأن يكون على بنفس المواصفات fixed. تشتري اليوم أو تشتري بكرة تكون نفس مواصفات المادة الصبغ هذه. This is what we call it, the quality of the product or customer specification. Even to control the temperature, as I said earlier, when temperature of the cooling media and heat exchanger rise up, so how you have to do to reduce maybe increase the amount of cooling, because when cooling media increase, temperature increase, the output temperature of your process will be increased as well. How to reduce it? You have to increase the feed, flow rate, or you have to add another cooler media to cool it down. Because if the temperature of heat exchanger increase, that might goes to the distillation column, or it goes to the reactor, or it goes to another process. So you have to control that particular issue. So this is the subject, dealing with two topics, process dynamics and process control. Process dynamics and process control. As I said at the beginning, we are going to study the process dynamic and then to study the process control. By the way, the slides will be submitted in the Moodle. As soon as your name will be there, you will see it. So far, it's not shown. In the EduWave, I don't know, it was a problem last semester. It seems to me nobody downloaded. I will try to add them in the EduWave as well. In both, it will be available. So you can look at them as well as on the textbook. I'm going to submit to you lectures written by, I put it in a slide wise, by one of the good students, as well as I add some additional information to it. So you can go for that particular, as well as my lecture I'm going to deliver in here. You've got it recorded. As well as you've got the textbook. So we will be give you a hand for any particular issue regarding the topics. As well as the assignment. The assignment, they are very important. Problems in the assignment, you have to solve it. You have to solve it, as I said, by your hand. This week I'm going to submit to you the assignment. The assignment will be required on Sunday. And to be clear from now, when we put time for the assignment, I should receive it. When I receive the assignment, I'm going to solve it. Any student delay submitting the assignment. After solving that assignment, I'm not going to receive it because there is no point. So what I'm going to do is give you assignment, you solve it, send it to me, I will solve it in the class, the assignment. So you'll have a clear idea. You have copy your assignment, you've got my solution or discussion together with you regarding the solution, and that's it. Afterwards, I will not going to receive any assignment for that particular number of assignment. Do not try to send it to me after solve it. That if you don't send solution for any assignment, there will be no solution. Bear that in your mind. If you have a doubt, you may ask me. Now I'm going to talk about advantage of or importance of the process control. Importance of process control. First, let me put it in this way about safety. Now,
from where we can get the assignment?
The assignment I will submit it in the Moodle
today,
inshallah, but I need your name to be fixed there. Still, they didn't fix it. Anyway, so what I'm going to do, you will get it either in the Moodle or by email if the Moodle is not fixed. The point, your name is still. Well, actually, may I suggest, now you good, you raise that point. If you can add your name to the Moodle, you start do it for the course.
Okay, but it's better to send to email.
I will send it by email, but what's your name? Actually, I can see.
مصعب.
مصعب الخليل.
لا مصعب مرزوقي.
مصعب مرزوق. In the Moodle, I need it in the Moodle. Why? Because I'll put a mark in the Moodle. You will see your mark on the assignment. I'm not going to accept any assignment or exam in the email. This is not, we know it is part of communication, but for the mark wise, it should be in Moodle. So even I'm going to send it to you by email, you have to submit it in Moodle to give a mark. At least you'll see your mark in Moodle. You need that. Right? Clear?
Clear.
Thank you. Now, first importance in safety. Nowadays, it is very important to work in a safe place in the plant. So, for example, we need to have, for example, a relief valve. Relief valve on pressurized process. Right? Relief valve, so that when the pressure, like in the pressure cooker at home, قدر الطبخ ضغط, you see when the pressure reaches certain point, that valve is open and you see the steam release. So that's part we're using a relief valve, for example, for the pressure system. Second, an example for safety, automatic shutdown in emergency cases or dangerous situation. Anything could happen in the plant. What you should have, automatic shutdown. You cannot depend on the laborers because everybody will get panic. So when there is a problem in the plant, it should have automatic shutdown in a sequence. Even you cannot close down everything immediately because we are dealing with a very, sometimes, not all of processes, but sometimes toxic and processing, it causes hazard. I'll give you example in a refinery, because they are dealing with the crude oil. A crude oil is a thick material. They do use heating to get fractionation in the distillation column, or to get other process, cracking process, desulfurization, or so many processes all depend on heating. You see, for that could be anything could happen. Fire could be caused there. So you should have an automatic shutdown, and that automatic shutdown should go for a certain procedure. I give you, for example, in some reaction, in benzoic acid, for example, production, if you reach a certain temperature, your material will get solidified. So even your equipment get damaged. This is regarding safety. These are brief, but some details will be given in two types of lecture notes I'm going to give you. One, it has more details, and other, it is lecture notes wise from a previous student. So you will have two types. Second, environmental protection. In the plant, normally we control the level. If we don't control the level, maybe your material will be leakage, overflow, and we are dealing with chemicals and many plants. So your floor, your maybe people who work in there get affected. So first things to prevent liquid or equipment from overflow. Second, sometime even for the environmental protection and to prevent pumping, prevent flow of toxic material, toxic liquid, to leak or let me say pump to river or sea. You see, in the plant, when we have a waste liquid, where we put it, we cannot dump it in the ground. It's not a solid. We have to pump it to the sea or to the river. So anything could happen. You should, for toxic material, you should prevent that by using a control system. 3, product quality. Product quality. So the importance of control and product quality, as I said earlier, to have a uniform product, good quality of product, to have a uniform product. حصل على منتج بمواصفات ثابتة. Concentration always will be same out of the reactor. Temperature always will be close to what your desired temperature from heat exchangers. The level in the tank always to be fixed. When fixing level, it means fixing flow. Fixing flow, it means your operating will be smooth. 4, we put it, reduce disturbances between integrated processes. Reduce disturbances between integrated system. As I said, sometimes what you have a reactor, right? This is a reactor, this is a feed. With the output of the reactor, it goes to a distillation column, right? to separate your product, and that part of the separation, maybe whatever you desire, maybe part of the output, it goes a recycle. Even though if recycle or not, these are with each other. You may have a heat exchanger in here. You see here three equipment together. The output of the first one, it goes to the second equipment, and so on. So the integrated system, any disturbance, for example, in the feeds, it will affect the reactor, affect heat exchanger, affect the distillation column. So a control system will try to minimize or reduce the disturbances among these equipment. So to be a good neighbor, for example, I write it always like that, to be a good neighbor. To be a good neighbor. Fifth, profit. Everybody needs a profit. But in the plant, initially when you design, of course, you make your feasibility study, and based on the price, you make a profit. But sometimes in control, we can make the profit more by utilizing, for example, energy in the plant. Utilizing, make a profit or increase the revenue. Increase the revenue, make more profit. More profit by first utilize the energy source, which is quite important. As you understand, the most expensive utilities, al-khidmat in the industry, is the energy. Utilize the energy. So for example, if you have a process you would like to heat, you might use the top part of distillation column and utilize the energy of that steam, right? We have an heat exchanger to condensate the vapor on the top, so we can use that as a source of energy, for example. So in this case, you utilize the energy, reduce the cost of operation. Second, you may have more product, or you have another material producing additional or additional product by using the control system, or increase the product, or increase based on your control system. So we talked about safety, environment, quality, profit, and be a good neighbors. The other issue is for monitoring and diagnosis. Monitoring and diagnosis. Monitoring and diagnosis. Actually, during the operation of the plant, many issues happening. Some faults will be there. Some deficiencies in equipment. How do we know that? We need to record, monitor. We have to measure the temperature. We have to measure the level. We have to measure the concentration, not for a short period, even for a long period. Give you a simple example. In heat exchanger, when we operate in heat exchanger, it's worked fine at the beginning. But with the time, we can see the temperature will not be as efficient as before. Why? Because when we record the temperature for few months, you find it drifting. Temperature, this is a month time, drifting down. And we may see the pressure drop will rise up for that particular period. How we do know? Because we've got a record by logging data. Logging logging data in the computer.
maybe
Now,
fouling problems دكتور صح.
pardon?
أقول لك ممكن يكون في fouling problems.
Yeah, true. That's what we said. That's it. I want to come. Thank you very much. So that's how do we know? We need something. If things are recorded, and we can look, is the drifting? We can look when there is a fouling, for example. That's for temperature. If the pressure rise up, that's guarantee it's the fouling issue. But if the pressure not rising up due to the blockage in the pipe, it means something else. We have to study it. Why that for that particular period. So this is monitoring. It's important for daily issue. So we can, it can be sent to the process engineer and fix the problem. For long period, it needs to be diagnosed that particular issues, not just the temperature, maybe other issues. Sometimes same problem happening regularly, maybe every week or every month. How do you know? Either there is a paper recording مثل مال تخطيط القلب ذا شايفينها, or there is a data logging there. You can come back. This is data can be sent to the engineer or to the people who designing the plant to look where's the deficiencies in that particular equipment. Or nowadays can be sent the signal remotely. Maybe the manager of the plant or the team or running the plant would like to see what's happening in the plant and they are far away. So that signal will, all signal of the plant, it goes to them by remote and look to the data. They would like to see what's happening in their plant. So you can see the importance of control system in many issues is related. Seventh, we can train people by using some software. That will come to that for trained personnel. That's we can use it by using in a modeling. That's another issue. Even we make it a profit by reducing number of people running the plant, because you are utilizing the control equipment and subsidize that by using the machine. Subsidize, I mean the labor by these machines. In this case, you're making a profit. These are major importance in control. Why we use a control system? Why we are using a control system? Now let us have an idea about the control. This is, I'm going to place to you the control equipment on control devices on some equipment, so you will understand it. And these you may use it at the beginning, because now you are many of you studying plant design too, and you have to design your equipment. And that, but each particular equipment, the instructor asks you to put a control loop. So this is just a preliminary drawing, and you may use it. It will help you. It will be useful to you to use it in your plant design. And if you reach the end of the course, you will understand what it means, these. But at the beginning, I'm going to give you a hand on that particular issue. And there will be a picture for that loops in the lecture notes. And in the assignment as well, you will have to draw a feedback or a control loop on the process. Let us consider first heat exchanger, for example. Heat exchanger. Heat exchanger, control on heat exchanger. Assume this is our heat exchanger. And this is a hot stream. Hot stream in, and this is your hot stream out. Hot stream out. And what we are using a cooling media. That is, for example, cooling water in, and here it is output, a cooling water out. cooling water out. So what we have to do for the control purposes, we need, as I said, to measure the temperature and control the temperature by manipulating one input variable. So it's better to manipulate, يعني نتحكم بالماء البارد اللي داخل. And measure what here we are dealing with heat exchanger. We need to control the temperature. Temperature is important for us. So what we need temperature element. This is, we call it مقياس لدرجة الحرارة. Temperature element. TE. Temperature element. المتحسس لدرجة الحرارة. It could be piece of metal. It could be capillary tube like in the refrigerator or in AC. And that temperature element, it sends the signal to what we name it temperature transmitter.
دكتور مثل السنسور يعني صح؟
هو هذا السنسر. So this is sensor. This is sensor. This is temperature transmitter. What it means, the transmitter sending the signal of the sensor. انت قرأت درجة الحرارة بس هذا الاليمنت ما يعطيك درجة الحرارة، يعطيك إشارة كهربائية. For example, in the car, you measure, there is a measurement for the temperature of the engine oil temperature or the cooling media, and you see in the dashboard the temperature. How that signal comes? Through the 12 volt DC, as well as the level of the petrol inside the car. Right, there is a sensor, and that sensor sends the signal بالأسلاك. So this is the transmitter. So the element that's sending the transmitter, sending a signal to temperature control. This is a temperature control. And that temperature control will send the signal where to the control valve. This is a pneumatic control valve. Sometimes they call it control element final. Control element. Sometimes in heating they do use a coil, electrical coil. That's why they call it final control element. Now, as you can see from this process, so what we have a temperature sensor. This is the sensor, measurement. We have a controller, we have a process, we have a valve, 4 elements we place on that particular heat exchanger. So the control elements require the control loop consists of first, process. Second, measurement. Third, controller. Fourth, control valve. You see, these are the 4 elements we need. The process, it is different. It could be heat exchanger, it could be liquid level, we'll come to that. It could be concentration, it could be concentration mixing tank, it could be a reaction, but these 3 additional are fixed. Measurement, controller, and control valve. And by the way, this is what we call it now, the closed loop. Now we are using what we call it a closed loop, control loop, or we name it feedback control system. Sometimes we go for example, normal heating system, continuous stir tank heater. We've got a tank. We heat it either by coil. We're using heater, and this is output, or we call it by a jacket. Or heating by a jacket is the same, right? This is on the mixing tank, right? This is same as a heat exchanger, same as a heat exchanger. So for heating, we've got a steam, and here it is condensed, similar to the drum, reflex drum. In before the reflex drum, there is a heat exchanger for that particular. When we'd like to cool or heat for additional heating if required, the output. For the top part, it is a condenser. It's different type, but it's similar to the heat exchanger, the early one. Now, what we need for those, it is a continuous stir tank heater. Continuous stir tank heater is similar to the heat exchanger. Why? Because you've got a mixer in the heat exchanger. What you have a baffles. It's like a mixer, right? In the heat exchanger, normally what we have, this is the pipe, and we have a baffle. So it is a mixer, like a mixer. So what we need for this particular, we need again a control system. We measure the temperature of the inside the tank, temperature transmitter or temperature. We put it transmitter. It's required element first, but both element and the transmitter, they placed together in an instrument. They call it transducer. This is temperature element, temperature control, and there is a valve on the steam. This is the steam. This is an example for the heating. Similarly here, we measure the temperature transmitter, temperature control, and there is a valve on the steam control valve. This is for the continuous stir tank heater. Let us have liquid level system. This is the tank. We need to control the level. So what we have input, and there is output. We could put the valve in here, and we could put the valve on the feed for the liquid. Here it is hand valve. So this is liquid level. You see, for this particular process, what we need, in similar manner, we need a level transmitter. We need a level control. And that signal, it goes to the valve. Again, so what we have, level transmitter. Level transmitter consists of level element, is the sensor, and level transmitter to convert the sensor signal to another. This is level transmitter. So when we write level transmitter, temperature transmitter, concentration transmitter, you name it, pressure transmitter, always consist an element, al-mutahassis, the sensor. These are three elements, as you can see. Measurement. So what we need? We measurement and controller. This is level control. And the valve, control valve, and the output. But we could have the level on the, here it is, level transmitter, level control, and the signal. You can see both are worked in the similar manner. But Here, when we control the valve in the output, we need different action to be there. So here, what we have, you see, when the level flow rate comes here, the level will rise up, the flow will go slowly up, and that will be reduced back. So the effect, it goes to the output. But in here, we directly control the input. It will be quicker here. For this part, the second one will be quicker than the first, but both are working in the same manner. Let me have a mixer tank. Mixing tank. You've got a material A with a concentration 1, X1, material B, X1, X2, and you adding another pure material A or B, pure A. It means X equal 1. Maybe here equal 0.2, this is equal 0.8. You mix it together and you have an output product. I mean, you need to have this. What you can do, you could have concentration, which is concentration is the conductivity measurement. So let me say, put it concentration or conductivity transmitter, conductivity control, and there is a valve on the feed. A valve. Sometimes we call it a transmitter for analytical material. For example, we measuring pH, we measuring oxygen concentration, we measuring component concentration, and here we put it AT control. So you see, this is type of control. We could control it in different way. We have those two streams. And this is the output. So what you can do, measure first one, A transmitter. It goes to ratio control. And there is a valve on here. Right? So you see what's the flow rate of first one. Put it with an multiplies by the number and control the feed 2. This is how it's work. If you need, here both the level is not mentioned. But if we would like to considering the level in here, this is our feed. This is the another feed, and you measuring here. It is your mixing time, and measuring the A transmitter, and then a control, and you need to control the level. So what you can do, here it is the valve. You see another loop, level transmitter, level control, and you control that particular issue. Output, this is a product. Similarly for mixing tank, if there is a reactor, A, it goes to B. Component A, and this is your output. So what you do, you've got, for example, you've got only one stream for that. That particular component A, so you can measure it. It is a transmitter, sorry, A control, and then it goes to the valve. Again, you can see there are 4. If you have 2 components, you may control the limiting. You may add level. Sometimes you have an exothermic chemical reactor or endothermic. You feed component A. There is a mixer. Your output there. This is your product. Component A react to B. And this is an endo or exo. You may use a cooling media. This is cooling in. This is cooling out. So what you do for control here, As you understand, there are big relationship with the temperature based on Arrhenius equation. So you may control the temperature, right? So what you do, temperature transmitter, temperature control, and we may use the cooling media out to control the reaction. You control the temperature rather than the concentration. Or you may have it both together. We call it cascade control. Or even you can have it both. Never mind, does not make any difference. You can take concentration transmitter, then concentration control, and then there is a valve on the feed. This is an additional. You may add a level for that. What you do here, level transmitter, level control, and then there is a valve in here. Now this is fully automated. Fully automated. Or you may mix two together. We call it cascade system. This is a reactor, by the way. This is a reactor. In the cascade system, this is your feed, component A, and you have a jacket. And there is your feed media. This is cooling in, and this is cooling out. And here is the valve. And what you did, you've got a control here. Temperature, this is the mixing. So let us use different color. So you measure the concentration transmitter, concentration control, and here it is the valve. And what you have a temperature here, temperature transmitter, temperature control, and there is a signal here. But you would like those to be mixed together, connected together, the two loops. By the way, what in the control we have what we name it desired value or set point. At your home, always when you open your AC, you have a desired temperature. You put it at 20, 22, 18. This is your desired temperature or whatever, or pressure. So you need your desired value. Here, for example, what concentration you need, here it is desired value. So what you can get, this is the temperature transmitter, temperature control. Then put it in. So this is a temperature control. There is a signal that goes here. You may get another signal from here to set the desired value. الاوتبوت هذا مال الكنترول مال الحراره يعطي اشاره لمن يعطيك الديزايرد فاليو مالت الكونسنتريشن سيت بوينت. يعني هنا اذا زادت الحراره انا من يزيد الفيد الداخل يزيد الحراره، فاذا هو يبرد وبعدين يعطي اشاره للكنترول مال الكونسنتريشن يقلل الفيد مالت الماده حتى تقل درجه الحراره. This is we call it cascade. Cascade control. Cascade control. Another example, which is normally we have the distillation column. In distillation column, this is the feed. This is the output. It goes through a heat exchanger. This it goes to a drum. Drum has a level, and this is the reflex. And there is a valve on the reflex. And there is a, let me put it in here, a valve. And the output, here there is a valve. And this goes to the output. There is a valve in here. This is the liquid, the bottom. And this goes to the heat exchanger. This is a valve on the steam. So the control loop on the distillation column, first thing we have to control the flow. So we measure the flow transmitter, flow control. We put it on the distillation column. Here we measure the pressure transmitter, pressure control. We control the flow of cooling media. Here we have level transmitter for the drum, level control, and that signal it comes to the valve. Here we can measure the temperature of the top tray, temperature transmitter, temperature control, and control the reflex ratio. Here it is, we have the level transmitter, the bottom right, because this is when the comes back, the steam. Level transmitter, level control, and thus controlling the output. Similarly, for the temperature of the first tray, temperature transmitter, temperature control, and this is it goes to the valve. As you can see here, all control element or feedback control consists of, in addition to the process, 3 instruments. One measurement, the other controller, and the other is the control valve. So this is the first chapter of the subject, and I suggest you to revise it. Just go back, just for when we say revising regarding the instrumentation and the importance of the control. Then you have to solve. Now you will be able to solve the. Let me stop the record. You will be able to solve the